tuhu pani encamukin nila kayo kastu.
Hello everyone, welcome to one of the extra classes I am now going to be adding to the Maya Cosmology course. If you haven't checked out the course, you can check that out. You can Google it or search it, Mayan Cosmology Course. So this is going to be a class, and I'm going to be recording a series of new classes of research, of more specific, detailed, and advanced knowledge regarding the Mayas, the Mayan calendars, and astronomy as well. So I've titled this class Milankovitch Cycles in Mayan Long Count. The first part of the video, I'm going to explain what Milankovitch cycles are, and that by itself is going to be very important, very useful to understand how the climate works, and I'm going to be making very punctual comments about that from the Mushuknina tribe and perspective, right? And the more I go into advanced courses, the more I'm going to have to start speaking from a lineage standpoint, where some knowledge, in knowledge, and specifically sacred knowledge, we get to a point when you can't just be completely universal. There isn't like a measurement for everyone. It's all about what lineage, what teacher, what construct you are making, right? And I'm going to be exposing the different constructs that are out there. I'm going to do that a little bit here in this video, and I'm going to do that in the other videos as well. And I'm going to go deeper into that and into going and looking at how other teachers are kind of making a construct regarding Mayan calendars. So one of the things I want to be very clear about in the knowledge and how this information is presented is that we see that knowledge is very often skewed, biased towards making things very positive. There's a very new age tendency to mask spirituality, to think that spirituality is being really positive and speaking really highly of things. And I have nothing against optimism and being positive. I mean, I'm all up for being positive. But we do see a lot of the information being clouded by this positivity that is really part of this system that we live in, where if you want to sell something, you're going to sell a lot more if you kind of inflate that knowledge. And I say this because I'm seeing even traditional Maya speaking, Quiche speaking elders that are doing this a lot. They are inflating the knowledge, and more than just giving you knowledge about the calendars and about the Mayas, they're really just kind of defending a very, in my opinion, an overly optimistic view about the Mayas. So another thing I want to say is, because then this, and I'm going to do a separate video about cultural appropriation and where I can discuss this in depth. and specifically for the circle of medicine and the Mushuknina tribe, where I say we can't have a universal way of teaching. We have to kind of say, okay, this is the way we understand it, and this is the way we're going to teach this, and that's a more honest way of doing it than saying this is the way for everyone and it's the only way, because that's what everybody has done before. And that touches onto New Age Mayanists like Jose Arguelles, and that touches into traditional native Mayan teachers who are also kind of, doing their thing, and I have to go a different way. Anthropologists and archaeologists, when they research the Mayas, they tend to project their own kind of cultural beliefs, their own worldviews, which are very Christian in a way, or not in a way. They are very Christian, even if they consider themselves atheists. They still have if you really break it down and really analyze the psychology behind their theories and their constructs of what the Mayas did or were, and we have to remember the Mayas are still alive, and that's the point. We are the Mayas, and I am the Mayas. Those who carry on the knowledge and live and practice the knowledge of the Mayas are the Mayas. The Gregorian calendar, we are in 2000, this is May 2023. So these are really new videos, so this is new information and new research I'm doing, and that I want to give you, and so that you enrich yourself with better knowledge. And I'm going to be doing a lot of this kind of taking away the positive, overly positive kind of belief-like information from the anthropologists and from the native Mayas, and kind of find a more neutral, a more kind of, well, really, what did they really know? I mean, let's stop praising and let's just get to what it is, right? So you'll see that this is important, and like I said, this is not good for business, and this is another thing you're going to notice, and I invite you to approach the different projects that we're working on, that I'm working on. If you would like to do what I'm doing, which is and which many even native people are not doing, which is getting out of the capitalist mindset of everything has to be sold. So to sell, you need to, you need to sell your thing. You need to make it look nicer than it is, and that's not really helpful if what we want is just knowledge and wisdom. And they're not going to say that, and because if you say that, and I'm saying this, it's not good for business. It really isn't good for business. So I'm already beyond business. I don't care if this gets views, if people buy the course or not. That's not the point. The point is to start building knowledge beyond the capitalist mindset. And you're going to see that a lot of native teachers, even if we do need to respect them and honor them, not all of them, but many of them are kind of falling into, they're even kind of starting into this kind of belief of that the modern world is that. So you have to be like that. You have to sell your stuff. You have to put makeup on the knowledge, kind of lie a little bit about things. So you say, oh, the Mayas were the most perfect astronomers that ever existed, and many of those statements are not true. Okay, so I'm going to be breaking that down And this is one of the very important pieces to break many things down regarding Mayan knowledge, wisdom, cosmology, and calendars. And we do need to look at each specific thing to do that. So I'm going to do another video where I kind of expose all the different counts and different calendars and different ways to measure time that the Mayans have. I normally like to say, and I probably say this along the course, that there is no one calendar. That doesn't exist. That could be a practical thing, but there's different ways to measure time, and the Mayas had different ways to measure time. Okay, so one of those ways, and there is a lesson where I teach how to read the long count. So this is not going to be that lesson. If you want to see that, go into the course, and there's a lesson on how to read and do the long count. But what I'm going to do is explain what the Milankovitch cycles are as far as modern astronomy understands it, and then how that relates to the Mayan long count, okay, and what similarities they have. So Milankovitch was so this is what I'm going to teach you now is taken from information sources that are available everywhere, the internet. Obviously, we have to take, not in this specific case, in other things, take into account, for example, in climate change, that there is agendas and tendencies by power groups or the elite, if you want to call them, to kind of skew information towards a certain agenda. So some of the information that is found on Wikipedia, or a lot of information that is found on Wikipedia and other kind of official or available kind of your go-to kind of source on the internet could be kind of skewed or messed with, right? But I believe that's not the case with the information regarding Milankovitch cycles. In fact, I think that they really can't not say, they need to say, and they say that in the information, that that's the big thing that drives the Earth's climate and the climate change, okay? The solar radiation, the position of the Earth regarding the sun, even more than whatever effect gases, carbon dioxide can have on the Earth. And I'm going to touch a little bit on that, okay? And I'm going to warn you that I come from a freedom standpoint, and I'm totally aware of, and I'm very good at filtering out the negative information, that information that is trying to be passed on to us to kind of program us, the social engineering. And again, saying that is really bad for business. So I don't care about business. If you want to help out, I mean, people that take this course have donated besides the cost of the course, and it helps. I mean, look at where I am. I still don't have a good enough camera, so any support helps. But it's not about that. I mean, what I really care about is evolving humanity into and helping out in constructing a true and faithful knowledge, really understanding what's happening, right? And taking out those beliefs, those dogmas from science. And I'm going to be doing that from, the Mayas, from native people and from modern Mayanists. They tend to elevate the Mayas and think. And then there's this projection, right? And you see that with all kinds of cultures and ancient cultures, to think that they were, and yes, they did have very powerful knowledge, and yes, they were the inheritors of probably ancient civilizations and very powerful knowledge. But sometimes our selling the story gets in the way of really understanding what it is. They really knew what it is, what we really can know, okay? Well, let me start with Milankovitch. Milutin Milankovitch, Serbian geophysicist, scientist that discovered, that theorized, and at first they didn't believe him, that the different changes in Earth's climate through the ages, because we have evidence, plain enough evidence to know that there were ice ages in the past, and then we can correlate that with from ice core samples with what we can observe in the movement of the stars, that our Earth is moving, its axis is moving. And then again, I'm going to be covering something that you can learn on your own, but I think it's good that I teach it, because I like to teach it, and sometimes I think I can explain it well. Okay, so the Earth has an axis where it rotates, right? And in that axis, we know it's inclinated from the elliptical plane. So there's this line is where the Earth is traveling around the sun. So you do a 90-degree kind of angle, so that would be kind of like your north, your galactic north, if you want. And from that, we have an angle of declination, which is right now 23.5 degrees. Okay, so and this is probably something that so if you already know this, skip it. I don't know if you enjoy listening to it. This should be pretty common knowledge, but I'm just gonna explain it, okay? Anyways, so the Earth, when you do this spinning thing, this little toy thing, I forget in English what the name is. You can say that when it's spinning, when it's spinning really fast, it's the axis is fixed. But then when it starts losing momentum, the axis starts kind of wobbling. Okay, so that wobbling. So there's three movements. Milankovitch discovered three movements. So one of those movements is called obliquity. So these are three dynamics, or three different types of movement that the Earth's axis has, and that determines how much solar radiation we get, and thus how that affects the climate. So let's start with obliquity. So obliquity is the angle, right? So the angle moves like this, right? It inclines and it has this movement like that, right? And it goes from 24.5, like the most angled degrees, and 22.1 degrees, and we are at 23 point right now. And this is also very interesting, and that this is not something that they write it on the NASA site. They got this information from NASA, and if you check other sources, you find a little bit of discrepancy between the exact numbers and the cycles and how much they last, okay? And I'm gonna do mentions about that, because I care about my science being exact. I care about really not believing something and really understanding what's going on. But one of the observations I make in these cycles is that right now, the present time, we are at the middle of all the cycles. We are in the most balanced position we can be in. and in very long cycles. So that's something to keep in mind, okay? And as I go further beyond the Maya Cosmology course, when I start going into the other courses I'm going to be given, that's going to be this moment in the present, and this information is going to be useful to know what's happening, and you know, what sense do we give that in a kind of a, in an all evolution, all of our humanity kind of sense. And I'm going to mention things that this is not the place to mention regarding that. But remember that we happen, just what a coincidence, we're right in the balance, in the most balanced point we can be in these cycles. As far as obliquity, we are right in the middle of the lesser angle that the Earth has, and this is obviously not to scale or not correct, and the hardest angle, okay? And this cycle, you know, from going, if you start at the 24.5, you know, you go to 22.1 and then back to 24.5, that takes 41,000 years. Now, this is really important. And I'm going to make a statement that emphasis, the understanding, much of the science really relies on emphasis. What do you emphasize? Because you can pass a whole bunch of information and kind of want to emphasize something. And so that can construct a kind of a narrative, an understanding, and so you can give real, true information, and depending on how you emphasize it, you can change the mindset of how that information is interpreted and taken. So that's something I'm observing. So one of the things I observe in general, in for example, in the site where NASA gives, or NASA, however it's pronounced, gives this information, is that they really don't emphasize enough the fact that they use the word around, you know, estimate, approximately. They use those kind of words, right? When, for example, they give the number of how long that cycle takes. What this really means, how I would emphasize it, is we don't know, or at least we don't know exactly, and that's the only truth right there. We don't know exactly. It takes around 41,000 years. And it makes sense why. I mean, to really know, we would have to be observing the sky for 41,000 years. Can we go back and know how the sun was positioned 41,000, or how the earth was positioned 41,000 years ago? You know, it hasn't been more than 100 years that we have this information, that we've been observing this. So take a look at how it's estimated, and yes, you know, it's probably close to this, right? Probably. But we've only observed for 100 years, so we don't know really exactly how things have been and how they will be. And wait till you hear my comments on climate change. So let's continue. So this is good to this is kind of the thing you want to write down if you want to do that. The angle, and about the angle, this is really interesting. I'm just going to say that still pending is a Andean cosmology course, and in the Andean oral tradition, there's a lot of saying regarding the angle, the inclination angle of the Earth, and I'm not gonna say it here because It's going to take time, but there's a reason for that. And there is some things that we wouldn't really even imagine or kind of believe regarding why it has that angle. That the Andins simply say it has the angle it has because of this, okay? So this is something to remember. The angle, the inclination, the obliquity. And the number 41,000 years. It takes 41,000 years, okay? So that's the first Milankovitch cycle. Sometimes it's also called nutation. And they say, and this is something I actually even downloaded a universe sandbox program that simulates gravity. And I'm going to try and research if this stands true. I mean, because I suspect that they attribute the nutation, the movement of the obliquity, to the moon, and all the three movements of the Milankovitch cycles, they attribute it to the moon, the sun, and the gravitational influences of Jupiter and Saturn. But do we really know? Next Milankovitch cycle is let's go with eccentricity. So what the name already suggests, center, eccentricity, how far off the center it is. So that is how you got the sun. So if you had a perfect circular orbit, that would be you would have no eccentricity. And that orbits, not only are they, some of them, like Venus's orbit is I think is the closest one to being completely circular with no eccentricity. But then the orbits themselves change due to gravitational influences. And this is another thing. Can we calculate that? I mean, we can get pretty close and with computers and modern calculations. But I truly believe from my soul that you can't get into exact numbers, and you cannot predict all the movements and gravitational influences and get like a perfect map and a perfect reading of what's going to happen. I truly believe that. So, because it's just way too complex. And then they're not taking into account consciousness. And if you take that into account, obviously for a very materialistic, mechanistic scientists, that wouldn't have any relation, how we perceive, do we influence, does our mind, can our mind influence the planets and the orbits? That's absurd. My spiritual intelligence tells me otherwise. Okay, so the Earth's orbit has a cycle where from times it's a little more circular and from times it's a little more oval shaped, okay? So that's called the eccentricity. That cycle says about, that's another word, about, I emphasize this, We don't know, but it's about 100,000 years. A whole lot of years. Okay? How does that influence the climate? Well, right now we're supposed to be in a close to a to the least eccentric, so we're like in the most circular, which would be the most balanced. So, but it's not completely circular. So these two words are also helpful. So the point where you're kind of farther away from the sun is the aphelion. I hope I'm getting this right. Yeah. And the point where you're closest to the sun is perihelion. And I hope I'm pronouncing this right. Aphelion and perihelion. Okay? It's kind of useful to learn astronomy, especially if you want to get into Maya cosmology. So that changes, in a cycle of 100,000 years. So right now, I was saying, we are the orbit is in its point where it has least eccentricity, so it's more circular. And it just so happens that when we are in the perihelion, the northern hemisphere has its winter, so the southern hemisphere has the summer. And if you don't know that, well, I'll say that really quick. Winters and summers are due to that angle that Earth has, so that it gets, so when we are on this side of the orbit, and the northern hemisphere winter, then the southern hemisphere has a summer, because it's kind of inclined towards the sun, and the other way around. So there isn't a winter and a summer that's universal to the Earth. You really have to say a northern hemisphere winter or southern hemisphere winter. I didn't know that, like, when I was little. And in fact, what they told us at school, which is really bad, is that it's this eccentricity what drives because it simplifies it, but it's by no means what's happening. That when we're closer to the sun, we get summer, and when we're further away from the sun, we get winter. In fact, what's going on right now is the contrary. When it's the northern hemisphere's winter, we're closest to the sun, so it's a little bit milder. And when we're in the aphelion, it's the southern hemisphere's winter. Well, I think the drawing is not correct here. So according to what they say, that makes things milder. Now, I'm going to talk now a little bit about I've actually, when I was 14 years old, 15 and 16, I had a weather station at my house. I've been an amateur meteorologist all my life. I can't say I'm an expert. I'm not. But I have a pretty good understanding. And one of the things I can tell you from my pretty good understanding is that, the solar radiation and how close you are to the sun and the inclination of the Earth and all those things play a role in weather. But another thing that plays a role, and I don't see this mentioned anywhere, but I know they know it, is that if you see most of the landmass is in the northern hemisphere. So you have, Canada, right, on this side. You look at the other side of the Earth, all of, Northern Europe, Northern Asia, Siberia. And when you get, especially in the winter, the more landmass you have, the colder it gets. Okay, so it gets a lot colder if landmass makes cold, right? So if it's winter, having the great, that's why Siberia and Canada are so cold, right? So you got a lot more landmass in the northern hemisphere, except obviously you have Antarctica, right? Which is like a whole lot of landmass right at the very pole, which is curiously not what happens at the North Pole. Right at the North Pole, the Arctic Circle, you don't have land. You have all around it, but not at the very, Arctic Circle. So I think, or I observe, that this is it has a lot to do with the driving the climate, the landmass and how much. So another thing that drives the climate, that they say that they do say in the websites, is that the more ice cover you have, the more reflection you get from the sun. The more the heat's reflected off, so you get colder. So that creates a snowball effect, so it gets colder. And that's what drives the ice ages. So if you really study it, it's just a whole lot of dynamics. It's by no means something that is simple to put in a little circle and say this is going to happen. It's just so many things that are moving, and in fact, the continents themselves are moving, and then there are things we don't know about and that are not being taken into account. For example, now that 2023, they're saying that we're going into a super El Nino, which is when somehow hot ocean water rises right near the equator, right? So this blue is hot, it's not cold like up here. And that obviously changes the whole dynamic of the weather in the whole world. The logic thing to think, if you are not open to something you don't know, would be that warm water is coming from another place that is going underneath. It goes below the surface water, and it surfaces right here, and that's what creates El Nino. When it's La Nina, the contrary is when in this part you get cold water surfacing. But I ask myself, do they really know where this hot or cold water? What if there were somehow reservoirs somewhere inside the earth where hot or colder water can come out? And I think if you research, you would find evidence supporting that. So all those factors, what drives the ice ages, there's evidences of meteorites hitting the earth. If you get a meteorite hitting here, and I think that's maybe probably what really shifted or ended the last ice age, is you had the big ice caps, and then you get a meteorite, so that melts a whole bunch of the ice, and then they do know about some type of kind of big pour of cold water that stopped the flow of, because here in the Atlantic Ocean you have a lot of warm water that goes up into Northern Europe. That's what makes Europe have such mild climate in regards to how far north it is. And it in fact and I observe this every year, when the North Pole freezes, you got a big gap here of what doesn't freeze because of this warm water. So if you cut that, you have some dynamic that makes that hot water stop going up there. It changes the whole climate of the earth. Okay, and they do know that something like that happened where, and they believe it was, cold water that poured from here into this part that kind of changed that pattern. But, it's kind of hard to consider meteorites, and, the best science is this. We don't know. Okay? That's the only real scientific statement right there. Okay, but we're learning, and we're approaching, a better understanding. We have to, and I attribute this to something that a psychological phenomenon we have as humans, that we cannot think negatively. This is, in an example, is don't think about a ball. Can you do that? So if I tell you, don't think about a ball, can you do that? You can, because if I tell you, don't think about a ball, you think about a ball. We can't not project. Our minds have to project. So when we getting information, if it's archaeological, whatever kind of information, scientific data we get, our minds immediately create kind of a scenario of how that information fits. And that's good, it's natural. What we have to avoid is thinking that is a fixed scenario, that we know that is the future, that we don't. I mean, we're kind of imagining that. We're seeing the tendency going there, but we don't know, okay? Okay. And that applies to the Mayas, because that's the other thing that happens, and I'm going to take this moment to say it. This is something I need to say. You know, if you go with one of these Mayan elders, a real Mayan elder that speaks Mayan, not a Mayan as like Jose Way or somebody that kind of culturally appropriated the Mayas. If you go to a real elder, they themselves, you'll see them fall into this praise kind of thing where they will say, oh, the Mayas knew everything. They had the most precise and perfect calendar that has ever existed. And so that's kind of extreme to the one side. You got the extreme to the other side. You get this, for example, this Mayan researcher, kind of Mayan origin, lives in Yucatan Peninsula. He's a academic. And at least he can tell you, no. I mean, they had pretty good knowledge of the observations of the sky, and they wrote those down. And we have some of the codices or codex where that's written, and the stelae and the temples. And it was pretty good, right? They had, taking into consideration how long and complex many of these cycles are, they had pretty good knowledge. And I'm going to get into, for example, Venus in another video, where I explain that. More than wanting to kind of know exactly when something was going to happen, I believe they were more interested in simply ordering things and giving kind of, some type of shape to time, even if it wasn't that precise. Okay, so it's not so this obsession for precision. It's a very Western thing, really, and it's something that can't be achieved. And if you study philosophy, you'll understand this. And mathematics, and the philosophy of mathematics, you can't get an exact. Some numbers are incommensurable, right? So they're perfect, like a circle, right? A circle is pretty simple and it's pretty perfect. You grab a compass and it's perfect. And it's really simple and really perfect. But try to translate that into numbers, and you start getting infinite decimals, right? So if you try to see the world like this, it's never gonna fit. You're just gonna be in an endless search of precision that is not there. It's not part of nature. That precision does not really exist in nature. Nature is imperfect because, and I'm not gonna get into this here. It goes into, that's what opens the dimensions, the different dimensions. Okay, so last cycle, Milankovitch cycle, is, and this is the interesting one, at least as far as long cycle, a long count, is the precession. Precession is that wobbling. So we saw that the axis tilts, nutation. The whole orbit shrinks and expands and comes back and wobbles. So that wobbling is the precession. So the axis of the Earth, we're pretty close, almost right now, is pointing to Polaris, is the star Vega. Okay. So this axis is moving in this circle, and that can also play a big role in the weather. It's also called the precession of the equinoxes, because the equinox is starting, they start moving, or in general, the backdrop of the stars shifts, right? If your solstice or your equinox is pointing towards that constellation, with the passage of time, 5,000 years later, it's going to be pointing, and here's the thing, a little bit further. Not totally somewhere else, no. It's just because it takes this cycle is, to come back to the same point. And this is estimate. This is, they try to calculate this because it's such a long cycle that you can only calculate it. You can't really know. We haven't been there, or we don't have records of being there. If we were there, if there was a civilization present there, and then some could argue that there is archaeological evidence of that, but still not uncovered enough. So it's estimated to take 26,000 years to complete this cycle. So in 5,000 years, we're not even halfway, right? So this would take 13,000 years, to switch to Vega, around 13,000. So in 5,000, we're not even halfway to that. So this is what's going on, 26,000 years for the precession of the equinoxes. So the Mayan civilization, at the climax, what is believed, now they're discovering that even as far back as 3000 BC, there was a climax in the central Petén region in the Mirador. That even throughout the course, and I kind of say this, I recorded the rest of the lessons in the course about 5-6 years ago. So now, with more confidence, I can state, and the archaeologists state, that the line between pre-classic Maya and classic Maya period is kind of being blurred out. That there were, in fact, very advanced or very kind of pre-developed places way before the classic time. And the best example is El Mirador. So even back then, 5,000 years ago, it was only a little piece of this big cycles. Okay, 26,000 years. Okay, so that's the precession of the equinoxes. That's the one, and this is how we tie it all to the Mayas. So up to here, I hope I've explained the cycles and you understand them. I'll read a little bit of something just kind of to finish off that part. Mathematical combinations of Milankovitch cycles confirm that between 1 and 3 million years ago, ice ages occurred at 41,000 year intervals. But about 800,000 years ago, they lengthened to 100,000 years, matching Earth's eccentricity cycle. And then I wrote, all theories, no clear answer. So it's all so approximate, and it's all so much of a theory. I mean, we can observe these movements, but the theory of how long they are, or how long they are, and how they affect us, and if they are exactly as we believe they are, that's a theory. We really don't know. So the one that is of most interest to us and that we're going to correlate to the long count is the precession cycle, the 26,000 year cycle, right? 26,000 years. Because it's very much like the 5 cycles of the long count. You'll find a thorough explanation of the long count in the section of the course where I go over the long count. So that's not what I'm going to do right now. It's recommendable that you go through that and then you come back to this so that you understand better. And I'm going to make some precisions that now some observations that now I'm starting to have with knowledge I have now, and with also the sovereignty, the confidence to really start stating what I really think, and start allowing myself to think what I think, or to think things through, and not just repeat the information that has been given to me. So the information that is given to us about the long count is 13 baktuns, 13 counts of katuns. And this is considered the long count, okay? Why? Well, most of the stelae, and that's how it's written. Stelae are inscriptions found in Mayan temples where there's a king being crowned. A lot of them are kings being crowned. There's a bibliographical purpose in these stelae, and obviously they need to have a date. And at least during the classical period, and the most studied and well-known sites like Palenque and Tikal and the classical sites, they all use this kind of long count system that doesn't go beyond the baktuns. I mean, just has up to 13 baktuns. But then there's a few stelae. Most stelae have this, right? And there's a few stelae. There's especially one in Quiriguá, in Honduras, that using the vigesimal system, it keeps adding kind of big stone, and they have names that I don't even know or remember. Different names for higher, 13 baktuns ton, or if you go up to 20 baktuns, you get one of these, and if you gather 20 of these, you go up. So there's a stele that has such a long date that if you add that up, it gives you like 64 million years, or 64 million years ago. So I think this long count kind of fixation is really only due to, I mean, a period of the Mayas where, yeah, well, why are you going to be recording such a long number? Let's just break it down, right? To what's really relevant, our era. And, but then I invite you, and in general anyone that's really wanting to study this and use it and understand it, to open up and just think beyond a fixed long count and think that maybe the Mayas, or the ancient Mayas, maybe they didn't have that fixation, in the sense that they were totally open to counting beyond this, and that this reaching its end, the end of the count, which according to the GMT correlation, Guttman-Martinez-Thompson correlation, which, by the way, there are other correlations, and I'm going to have to do a video about that. I will be doing a video about correlations, and then I'm going to do a video about a big mistake that is found in all correlations and all calendars, and how that screws up everything we know about calendars. Mayan calendars. But the most accepted correlation is this one, GMT, Martinez-Thompson, which, according to that correlation and the stele found in El Tortuguero that has the date 130000, so that's the end of the long count, which is about 5,200 years, which then, according to this correlation, was in December 2012. Okay. So, and then I have a video coming for you about just this matter, 2012. What happened? So that, does this have to reset? Really? Or can we just keep adding? We could go to higher Baktuns. This is going to go to 14. 13 is like this. We can go to 14 Baktuns. Right now we actually are in 13,000 and whatever amount of tunes, winals, and kins we've come from 2012, if this correlation is right, which is going to become, all the correlations are going to become kind of obsolete, with what I'm going to share about the big mistake, which is the adding a day every 4 years. Okay. So this cycle, if you add those 13 Baktuns, right? 13,000,000, it gives you 5,200 sidereal or Mayan sidereal years, or tun or tunol, which are 360 day years. And regarding that, another thing I need to mention, I'm going to get to what I was going to mention, but this is the moment to bring this up as well. Some people try to make sense of this 360. So I think I'm going to postulate that the Mayas care a lot about symmetry. And even though we see a lot of symmetry throughout the universe and in the stars, and especially in the Earth, and how Fibonacci sequence and whatever, nothing is really precisely exactly symmetrical. The cycles, we know that the Earth takes 365.2422 days or rotations to go around the sun. So it's not precise. So we know that 360 is the amount of degrees that we can evenly divide, how we can divide a circle, the amount of degrees we have in a circle. So that's symmetrical, right? So I think the Mayas, and we're going to see this in other videos I'm going to do about the moon calendar and so forth, they and Venus, they cared about symmetry and not so much about precision or knowing when or predicting when exactly is this going to happen. Now, the archaeologists do have a narrative that because they project their kind of religious. They think that the Mayas were also into kind of, and yes, if you read Mayan texts, they have such an extremely poetical way of speaking, a sensation of them being, you know, oh, so concerned about the eclipses, and the eclipses cause catastrophes, but I think there's a little, you know, an incorrect cultural translation that the archaeologists do, and anthropologists and academics. And they don't really thoroughly understand the writing and just the language that the Mayas used to express themselves, and that they weren't so extremely, as they think they were, concerned about cataclysms and about and as this, they state, using the equinoxes, or I mean, sorry, the eclipses to manipulate the masses. Wouldn't that be kind of a projection of the European culture? Maybe there was some of this, but maybe it wasn't so much of it, right? So maybe they weren't so much concerned about predicting the eclipses. And talking about eclipses, that I have to do that in the Venus video. This is not place, but I will be saying a lot of things regarding that, which is just important things to know. And regarding that, so they cared about symmetry. They cared about numbers making sense. And knowing that, you know, we want to think that they were measuring, and this is the whole point of this video, and because I've gone to presentations of investigators, and they just come out and say the Mayas knew about the precession of the equinoxes and had a calendar that measured it. The long calendar. Bold statement. And it's pretty close. I mean, there are some, you know, the only thing we really know is when the numbers match. But do we really know? Did they really know? I believe there's a more than trying to measure exactly what cycles are happening, specifically these extremely long cycles. Maybe they did inherit some type of ancestral knowledge. Maybe they did through channeling and through, you know, augmented perception, download, you know, many people like to think that it was aliens that brought them information and technologies. I am not so much of that. the more I know, the less of, of that position I have, at least in the sense of, I don't think that whatever other entities live in the universe, I don't think they are necessarily material or have a body. They can be inorganic. So they don't need spaceships to come here because they don't have a body they need to bring. But then we can totally contact them and they can maybe teach us a few things. And maybe that's what happened. And maybe it is recorded in the long count. But do we know? What do we know? What if we just stick to what we know instead of giving way to this mental tendency of wanting to complete the picture? What if we just accept the little bit we know? Okay? What's the little bit we know? Well, you know about the long stellate that measures 64 million years. We know that the long count adds up to 500 Tunov, or 360-day years. As I was saying, the Mayas had these type of counts that really precisely don't measure. I mean, this doesn't measure, this 360 days doesn't measure anything. There's nothing that repeats itself that we can astronomically observe that happens every 360 days. It kind of, if we add it up, matches this. So I'm going to show you how. If you translate these 5,200 Tunov into tropical years, into 365.24 day years, we get 5,125. Tropical, that's the way to say that, the real years. .39. So this decimals really fuck up everything. Sorry for that language. Because if everything just fit together, but it doesn't. So this is a whole Batum count, which are the stellae that are found in most classical sites. I mean, that's kind of like the standard dating system that the Mayas, during the classical period, and the post-classical period, and the pre-classical period, had. Okay? With the exceptions of these very few stellae that have these really way longer counts. Okay? Which I will be researching more into. Okay? So 5,125.39 tropical years times 5 gives you 25,626 tropical years. Okay? Which is 9,359,999.9 days, which is 25,999.9 tun of sidereal or tun years. Okay, so remember at first when I was explaining Milankovitch cycles that this number is really this number. So we don't know if it's not exactly 26,000 years. We don't know exactly what it is. So take a look at this. If we have 5 long counts, it is, as far as tropical years, 25,626. And if you measure it in 360-day years, it's pretty darn close I mean, you can't get any closer to 26,000. So that's the clue that gave the inspiration to these investigators that you'll, if you get into reading and listening and you know, that's why I'm gonna give you my my point of view on it. You know, they're gonna assert that they knew about the precession of the equinoxes, that this calendar measured the precession of the equinoxes. Okay, well, yeah, well, maybe, well, yeah, okay. That's a pretty darn good coincidence, right? But that's all we know. And this times 5, I mean, yeah, if you do this times 5, you get this number. But can we, I mean, where would, I mean, is there somewhere that said count 5 long counts? So that's a relation that we can say Milankovitch cycles, or at least this one of the cycles, the precession of the equinoxes, has with the long count, that is 5 long counts. But then, as I said not too long ago, you know, the long count maybe could go on longer. You know, it wasn't, in my opinion, it's not measuring anything. It's just a practical way, and I say this in the videos where I teach the long count. It's just a practical way of adding up days and years. One of the other things I observe is the Mayas gave a lot of meaning to the numbers. So the numbers have meaning just by themselves. They don't have to reflect on the sky. They don't have to be precisely, you know, they can come close to a cycle in the stars, but it's not about precision. That's the thing. It's about meaning, and it's about ordering. Let's order up our days so that we can make sense of them, so we can add them up, so that we can put them on a you know, we've been here a long time, let's, you know, put a date that makes sense to that long time, using our mathematical systems. I think it was really more about that than trying to prove to the world we know about the precession of the, maybe they did know the precession of the equinoxes. Maybe it's just a coincidence. We don't know. The wrong thing is, and remember the emphasis, is having somebody, instead of doing what I'm doing, kind of just giving you the numbers and the sense they make, saying the Mayas were so advanced that they knew about the precession of the equinoxes. And so that's, like I say, a bold statement where, yeah, maybe they did. But I mean, what evidence, except the almost matching numbers, do you have to support that? Okay, that's what I like to stick to. And also, you know, trying to impress instead of taking into account other things like ordering cycles, giving some mathematical sense, some symbolical sense to the numbers, and that's something that's you're gonna see reflected as well in the Venus video, where the advanced video about Venus I'm gonna be doing, and the Mayas, how they understood Venus, and the advanced video about the moon and the moon cycles, where they're pretty good examples that they cared more about balancing out the cycles, right? Maybe they're not really about knowing or showing when exactly is Venus going to show, but rather having that cycle come close, in the statement. The Tzolk'in or Cholkich calendar, the 260-day count, sacred count, is a Venus calendar. I am totally with that statement. It's too bold of a statement. It's trying to simplify something that is a little bit more complex. And here I've given you information tools to understand those complexities, which are, they like to order things, right? So if I'm going to speak briefly about Venus. So if the morning star and evening star cycles are close to 260 days when they're visible, they are not 260 day long. It's not about measuring. It's not a calendar that it's not the measurement of that. It's just kind of coincides. If you want to call it a mathematical resonance, comes close. And you're going to see a lot of those mathematical resonances through astronomy and orbital dynamics, and there's things called the orbital resonances. Universe likes to resonate and come close to two completely different things, make kind of fitting together, but they, if you make the numbers, they don't fit together like as precisely as we would like to. So the statement, this is the calendar of this is the measurement of it's not my statement, okay? So I don't say that the sacred count is a Venus. The only very precise cycle that lasts 260 days, which is, by the way, a little bit off of what doctors, modern medicine likes to say about is the gestation period of a human being. That's what should be or is 260 exact days. And to me, that's the measurement of the Tzolk'in. But not only that, it also kind of coincides with the morning or evening phase of Venus. Things that come close, things that almost match up, things that resonate. But let's try to get away from that. This is the exact, this is the precise, this is the... I truly believe the Mayas were kind of beyond that precision. Let's call it the addiction for precision, right? The obsession for precision. Maybe that's a Western thing. Maybe the universe starts making a lot more sense if we can get our minds away from finding that precision and trying to put that precision where it doesn't go. So I hope these reflections and this class has been helpful. All this information has been helpful. Speaking with my heart and with my mind. Thank you for listening.